By the end of this video, you will have an understanding of how to make a basic 2D platform AI using Unity and C#. For the best tips and tricks on game programming and game development, subscribe to my channel and hit the bell to be notified when I post new videos every Monday. If you are already a subscriber, thank you. It really means the world to me. My name is George Wulfers and I'm a professional game developer. Let me guide you on your game development journey. Be sure to watch this video to the end to find out how you can get more free learning resources. Step number 1. Basic platformer AI. So what is artificial intelligence or AI? AI is when a computer or machine performs tasks that are said to need intelligence to get those tasks done. This can be anything like traversing a maze or playing a game, like chess. So what is an agent? An AI agent is an entity which acts autonomously. It performs tasks to achieve goals within an environment. One example of this can be an AI in a game where its purpose is to guard something and kill anyone that comes near him. Basically, an AI takes in data as inputs and then processes it and then outputs something based on that data. For example, let's say we have a basic AI that has several states: idle, patrol, chase, attack, and dead. And let's say he can only sense players at a distance of 10 meters in the direction he is traversing in. The AI will get some inputs, like objects he is seeing, through either raycasting or some other means. If one of these objects is then the player, he will check the distance to that player and see if it is 10 or less meters in distance. He will output a change in state to chase or attack the player. If then the player hits him, he will take damage as an input and produce a result of being dead or not based on how much damage he was dealt. Today we will be creating a simple AI that patrols along a path. If the player touches him on the sides, he will damage the player, but if the player lands on top of him, he will die. In order for us to create a more intelligent AI, we will need to talk about state machines, which we may talk about in our next episode. So don't miss out. Step number 2, making the script. All right, so let's open up Unity and let's go into the scripts folder, gameplay, and let's create a folder, call it enemies, and inside of that folder we're going to create another folder, we're going to call it basic enemy, and then we're going to create the C# script called basic enemy, and let's open it up. so we just wrote a little code. If you're probably wondering what the hell is going on, I'm going to explain it right now. There's a lot to cover, but it's pretty simple. It's nothing to be afraid of or worry about. So let's start up here. So here at the top of the script, we are adding the package that we created for the player stuff. So in this package, WG Platformer Gameplay Player is going to contain all of the, we can access all of the scripts for the player, which includes the movement controller. Okay, so that's what we need it for, because we're going to do something pretty cool whenever we touch the enemy. This, as you know, we have our namespace here, and let's look at the first one. So the first one is going to be, so what we wanted to make is an enemy that goes kind of like in Super Mario again. Where you have those little Goombas or whatever they're called, and they're walking back and forth. They don't really chase you. They don't really care about the player. They're just minding their own business, going back and forth. So that's what we're going to do, right? So in this scenario, I'm not sure if they had this or not in their system when they made the game, but in ours, we're going to have a list of points where we want those Goombas to go, right? So we need that, and it takes we're keeping the transform as always, because we only care about that for the points. Maybe later on we'll care about something else, and maybe we'll make a class for the target points or path points, whatever. Okay. So next we need to keep track of the current point that we are in. Not necessarily the exact point or the actual point, but the index within that list. Then we need a Boolean flag to tell us if this enemy is alive or if it's dead. If it's dead, we're going to do something, and if it's alive, we're going to do something else. Then we have a walk speed, that is, the rate in which he walks, obviously. Then we have distance to point, and the reason why we set it to the maximum value of a float is because this value is going to determine how close we are to the point, and if we start at 0, then it's going to automatically skip that point, even though we're probably pretty far from it. So we need to make sure that that distance is as big as possible in the start, so that when we calculate it, we can actually see how far we are and then move towards it. And then the final one is the arrive threshold. This is going to be the distance in which the preferred distance that we want to allow the enemy to switch from point A to point B. You'll see how this works. Okay, so now in the fixed update, as always, we're not really having any physics here, but we probably should at some point add physics to this object. Right now we're just trying to make the simplest thing, and then we add complexity, just like we did with the camera follow, or the follow camera. Okay, so anyway, here we're only going to care about this update if it's alive. And then after that, what we have to do is we have to make sure that the points have points in them. So we got to make sure that the count is actually greater than 0, because if it's 0, then we don't need to go through any points, and that's it. And if the current index that we have, if it's less than the number of points in this list, because if it is over it, if we try to access an array or a list with an index that is greater than the amount allocated, we're going to be accessing data or memory that is not for us, that is not there, that is probably private somewhere else. And it's going to give us an out of range error, and it'll crash the application. So this is very important. We're gonna make sure that we go from 0 to count -1, if that makes any sense. So the next thing we gotta do is we gotta extract that transform and make sure that it actually exists before we actually use it. And then we get the actual location for that point right here. Then we calculate what the current distance between the enemy and the actual point is, and if it's greater than the threshold, then we're gonna advance to it. And this time we're using a lerp function. It's a linear interpolation function. We can write our own if you guys want to. It's pretty easy to do, but pretty much what it does is the first thing is going to be in this case is a vector. So we got vector 1 coming in, and then we have vector 2. So you can think about this as the starting position and the end position. And then this number here is it's pretty much a value that is between 0 and 1. And what this value is going to dictate, it's going to be like, okay, between the so that value between 0 and 1 is going to dictate how far along this line here we have. So if it's if that is 0, then we're going to only look at the starting point. And if it's 1, we're going to look at the end point. But if it's anywhere in between, we're going to mix these two values and go from 0 to 1 to these two vectors. So essentially, it'll gradually go this way. Okay? I hope that made sense. If it doesn't make sense, make sure to comment down below and I'll try to explain it better. But now if we have arrived to that threshold or to that point and we're within that threshold, then we're going to advance that current index so that we can go to the next point, and we're just going to reset that distance value to be the maximum float again. Because if we just leave it the way it is, it's going to be like, oh, we arrived to the next point, which we didn't, and then it'll look for the next one. And if we are over, meaning that we already went from point A to point B, if we only have 2 points, this is 0, this is 1, so when we're walking from whatever we are to here, it's going to be at 0, and then when we walk from point 0 to point 1, it's going to be at index of 1, so we're walking this way, and then once we're there, once we're at the end, we're going to be at index of 2, which is over the actual point count that we have. So once that is true, then we're going to loop that back to 0 so that the enemy goes back over here and then goes back here and pretty much does this, you know? So that's how that's going to work, and we're going to also reset the distance to be the max value for the float. Now, so this is going to be handling the collision between the enemy and the player for now. And the way we do this is because this is 2D, we have an onCollisionEnter2D function, and we take the collider or collision2D object who collided with this object, and we just care right now about the player. If the player collapsed with the enemy, then we're going to be looking at what we do here. So the first thing we got to get is the direction to the actual player. This is very important in order for us to do what we want to do. So the way it works is that we have the enemy here, and then we have the player here. If the player hits the enemy straight on in either direction, the enemy's going to get the player's going to get damaged by the enemy. The only way to kill this guy is if the player goes here. So we have to get the vector that goes from this guy to this guy, so we know where we are looking at, and we're gonna do a calculation with a dot product based on the up vector of the enemy, and that's going to determine where we are located around the enemy. Okay, so the dot product pretty much has a value between -1 and 1. So when it is closer to 1, that means that those vectors are closer together, like this. If it is 0, then they're perpendicular. So they're like, one's looking this way and then one's looking that way. And if it's -1, it's going to be like this. We're looking away from it. So this is that's what's happening here, right? Oops, didn't mean to do that. So then we have a box here, and anything that is above 0.5 is going to be pretty much up here. It's going to be right there, like it's going to be like a V. If this is the vector right here coming up, 0.5 is going to be at a 45 angle from that from this guy. Yeah. So that means that it's going to encompass pretty much all of the top here. And anything else around it is going to be damaging the player. Okay. So once we determine where we are around the enemy, if it is above it, we are going to just kill the enemy instantly. Then we're going to get the movement controller from the player, and we're going to add a force to the enemy, to the player, so that when you go like this, it does that little bloop, jump thing. And you'll see how that works. Pretty easy with the setup that we have. And then we're just going to display a message saying that the player killed the enemy, just so that we have actually, so we have a visual, and then we have this as well, which is just text. And then we're going to destroy this enemy, and that's going to be it for that. And if the dot product is less than 0.5, meaning that we're not above it, we're somewhere around to the sides of it or underneath it, if it happens to fall above us. But I don't think that's ever going to happen. So then here we're going to get the movement controller, so we probably should get this somewhere else so that we don't get it twice. But anyway, and only if this enemy is alive will we add force to the player. So pretty much the way that force works is that you have a direction in which you want to apply that force, and then you have the actual force or the power of that force, which in this case is 5, and up here is going to be 10. So the direction to the player is going to determine the force direction. So it's going to be, so if the player's up here and it's falling down, it's going to pretty much repel it away from the enemy. So that's how that works. And we're just going to display that as well. And we've never done this, I don't think, in any of my videos. So this is something cool. We're just going to visualize where the points are and the actual radius of the arrived threshold so that we have some visuals. We may also do that to the follow camera so that we can actually see the little safe area as well. Okay, so let's go and move on to the movement controller and let's add that function. And let's add it right there. This needs to be public. Add force. And it's going to be a vector 3. And it's going to be force, direction, and then we're going to have a power or force power, I don't know, and we're going to say velocity plus equals force direction times force power. And if you take a look here, it's pretty much the same as that, right? So we can actually modify this to be add force vector 3 up, comma, jump speed. And it should work the same. And here we should now have it be good. And I guess let's I mean, there's nothing really that I have to explain. We're just adding to the velocity what the direction that we want to add the force in, and the amount of force that we add to it is, and it's just gonna make the player go boop like that. That's all you have to know. I mean, it's that easy, I guess. So in here, in the follow camera, let's do that visualization thing, right? On draw gizmos. So there's two functions. There's on draw So there's two. There's selected and then there's gizmos. We want gizmos because we want to not select it. We just want this one because we want, I don't know if you can see it, the IntelliSense, but we only want the onDraw gizmos function because we don't want to just have it selected. We want to see it at all times. All right, so let's continue with this. So, pretty much how this works is that we call gizmos, and when we want to add a color to a certain object, we just do color and then we specify the color. So in this case we're going to do yellow for the safe area, and then we're just going to do some calculations here to determine the actual bounding box. So we get a min x, min y, and then we get a max x and max y. So the max x, or the min x, is going to be the transform position.x minus the width safe area. And then the min y is going to be that as well, but instead of width, it's going to be the height. And the max x is going to be that, and the max y is going to be that by the height safe area. And then we just gotta draw the lines. Loin. Top loin. That's funny. I'm sorry, but that was funny. Left. All right, so to draw a line, we just do draw line. And pretty much what we're going to do is we're going to say new vector 3 and new vector 3 here. Okay. And we just constructed based on our min and maxes. So for the top line, we're going to have a line here, point here and point here. So it's going to be the min x, right? And then the max y, and the z is going to be 0. And then we have the other side, which is going to be the opposite of it. So it's max x and max y. So this one's going to be the same, and 0. Okay. And we'll just leave them like that, close together. So the bottom one, all we gotta do, since it's the opposite, we just gotta say min y on both cases. The right side, we have a point here and a point here. So the x's are gonna be the same. And that's gonna be max actually. But we're gonna start at max y and end at min y. And for the left side, it's going to be similar to this one, and the only thing that's going to change is the x on this side this time to min. All right, and we are also going to add a kind of like a line or a ray that tells us where the camera is going towards, and that's gonna be easy to do. We just want to start, which is going to be the R position, and we just gotta make sure that the Z is going to be 0, and we want an end point, which the end point is going to be the follow transform position. And then we just do gizmos color, and that's we're going to call, say red. And then we're going to do another line. I don't know if you guys saw that, but my screen just turned black, and I don't like that. But anyway, we just start and end. And that's pretty much it for that. Let me know in the comments below if there's any AI that you have seen used in platformers that you would like me to implement for this series. Step number 3, testing. Okie dokie. So let's go into Unity, make sure everything compiles, and looks like it is compiled well. Let's go here, and as we can see, we already have that. We can already see the things that we set out to do, and if we change the area, we can see that it changes. So we can say, and there we go, right? So we have the safe area, we got the distance to the player, and whatever. So now let's add our enemy. So we want to go into the create menu, I guess. Go to 2D objects and go to sprite. Let's rename this guy to be basic enemy. And we're going to be using the UI sprite. And we're going to be setting the draw mode to tiled. And we're going to say, I think it was 0.5 on both width and height. And make sure that we set this guy like that. Make sure the Z is 0 and positioned where you can see it. We're going to change the color to be something like orange-ish. And we're going to add box collider 2D, and we're going to make sure that we put it all over the player, the enemy. Boom. Once we do that, we want to add our basic enemy script here. And let's make some space for us to see, because I know last video we couldn't see stuff. So let's add 2 points there. And let's position him right there. And we're going to create an empty object. We're going to call it point 0. And we're just going to go in here to that little box and select that orange thing. Go to 0, 0. Let's actually copy this guy's Y, put it there, and just move it to the side here. And copy paste, rename it to point 1, and put it on the opposite side, right? And then we go back to the enemy, and we put this guy there, and this guy there. For the walk speed, let's do half of a point, and the rest stays the same. Save everything, and let's start somewhere else. Let's start over here somewhere so that we don't crush the enemy as we spawn. But let's give it a go. So we can see that our enemy is going from point A to point B. And as you can see, as it gets closer to that point, it starts slowing down. We don't really want that, but we can fix that with doing the physics calculations. Let's go ahead and, before we actually jump over there and get hit by him, let's make sure that we have our error on the console ready so that we can see it. So let's stay there, and boom, we got hit. And it says enemy damaged the player. Alright, so now let's jump on top of him, if we can. Boop, boom, and there we go. Player killed by enemy. Player killed enemy. And as you can see, it propelled us. And that was pretty cool. Congratulations! Now you know how to make a basic 2D platform AI using Unity and C#. If you would like to follow along, I have provided a link to our project in the description below. Don't forget to also get our free guide where we explain in detail more about 2D platform AI for your games. Don't forget to go to our Facebook page and say hello. We would love to hear from you. check out these other videos next on how to make games using Unity. And if you like this video, hit that like button and be sure to subscribe and share this with your friends. Thanks for watching and see you next week.